this is the blue bottle experiment, and this demo will show you how the concentration of something in a reaction affects the rate of that reaction. So in this specific reaction, it's going to be the concentration of oxygen and how it affects the fading of methylene blue. So in the bottle here, we have mixed up sodium hydroxide and glucose in about 300 milliliters of water. And when we add the methylene blue, it will start to fade over time, and that's because in these alkaline conditions, which is caused by the sodium hydroxide, the glucose will start to change the oxidation state of the methylene blue, and it goes clear. And once you shake the bottle up again, it goes blue. So first of all, we have to add the methylene blue so that we can actually see something going on. And it doesn't really matter how much you add to this, just so long as it's blue. And you shake it up so that it's mixed in there. And then usually it takes about 30 seconds for it to fade back to clear. And at that point, the glucose is changing the oxidation state. Time, we'll show you how it works. Shake it back up, reintroduce the oxygen, concentration of oxygen's in there, and again it starts to Eventually it starts to fade.
You can shake it up about 20 more times and the concentration's still going to stay blue. Once you hit that probably 30 mark, it's not going to turn as dark of a blue anymore, but it is reusable in the experiment to test it.
And you'll know it's about done reacting when it turns this really ugly yellow color and it just won't turn blue anymore.
Yeah.
Like this one, like this one here. So as you can see the difference, that one's about done for. Kind of in order to show how the concentration of oxygen affects the speed of this reaction, you can shake it up more or less, and it should affect the rate of fading. So we're going to try to time this and see how long it takes to fade when we shake it up different times. Okay, so we're just going to do this one time just to see how long one reaction takes, and usually it takes around about 30 seconds, so we'll see. So it's blue one more time, and we're going to start the timer. That's about the amount of times I've been shaking it. Actually a little longer than 30 seconds. Oh, there it goes. A little bit longer. All right, we get it. And that was about 40 seconds. And it's still a little blue at the top, but for the most part it's clear. So that took about 40 seconds. So now we're gonna shake it probably about 5 times. Let's do about half that, and then we'll do double that and see how that affects the rate of the reaction. So we'll reset the timer. 4, 5. And we'll start it again. This is the not so fun. So that one actually took about 32 seconds, so about 8 seconds less than the first time that we tried it. So now we're gonna do it one more time, and we're gonna shake it about 20 times, so quite a few times. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're going to start the timer one more time.
So while we're looking at this one, we can take a look at our old one that we have. See how it has discoloration. It's not clear anymore, just from overuse. So we can just kind of see how much longer this one takes to turn blue and go back to clear again.
See, you can tell the difference in that one too. It's kind of a more light purple color. It used to be the same color as this one, but. So we're approaching 40 seconds, which is what the first one took. And it's starting to go a little bit longer.
A little bit.
And
About 2 seconds.
So that one took about 3 seconds longer, and this one is still like purple. So you could really see when we shook it about half the number of times, that was about 8 seconds, and then the second time took about 3 seconds longer. And again, that's due to the higher concentration of oxygen that we put inside the solution. So it takes a lot longer for the glucose to reduce the oxygen in this reaction. And so that is the blue bottle experiment, showing the fading of methylene blue and how the concentration of oxygen affects the reaction rate.
When looking at concentration compared to rate of reaction, we see that when you increase your concentration, the rate of reaction is increased also. This is because whenever you're increasing that concentration, it's giving you more of the reactants or ions in the reactant products. On the other hand, when your concentrations are already high, there's a limit that becomes where the concentration is so high that it'll change little to the rate of reaction. When comparing temperature to rate of reaction, we see that increasing temperature increases rate of reaction and decreasing temperature decreases rate of reaction. We know this because when temperature is lower, the molecules are slower and collide less, which gives us the conclusion that when the temperature drops, so does the reaction rate.